Okay, well, we'll talk about grain rules now. We have to have specific separate rules for vessels that carry grain. And of course the term grain, it could include wheat, barley, rice, seeds, all sorts of different particles. It has a very low angle of repose, bulk grain, and if it's not effectively secured, it will shift as the vessel rolls in the seaway. And unlike liquid, as it shifts, when the vessel comes back upright, not all of the grain will come back. So that will definitely have an effect on the GM of the vessel. So what we have to do, we have to accept that voids in the compartments do occur. And what we do, we use what we call healing moments due to the grain shift. So we accept that there's going to be a reduction in our righting levers, and we feed those into the stability data so that worst case scenario, we make sure that the vessel is secure. And there are basic requirements regarding the grain rules. The vessel must be upright when the loading is complete. The angle of heel due to the grain shift shall not exceed 12 degrees, or the angle of deck edge immersion. So on our graph here, which we'll look at on another video, when we draw our healing curve with the lambda values, where it cuts the GZ curve, that would be the measurement of the heel of grain due to shift, and it can't be more than 12 degrees. And in our diagram, this statical stability diagram, this residual area here between the angle of heel due to grain shift and this value here, it's called 40 degrees value here, but I'll just go through that shortly. This residual area here must be not less than 0.075 meter radians, and your GM initially when you sail must be more than 0.3 of a meter, must be 0.3 or more. Okay, the minimum is 0.3. When we talk about this value here at 40 degrees, it could be one of three values. It's the maximum difference between the two curves at 40 degrees. So when we draw our curve, as we draw our GZ curve, at some point there'll be a maximum value. And when we, with our healing arm curve here, this lambda curve, we would draw that up as a parallel line to cut the curve, and at that point where it's maximum, we'd read at what the angle is. We would also go into our angle of heel data with our displacement and look up the angle there, okay, which is the angle of flooding. We would compare those two with the angle of 40 degrees. Whichever is the least, that's the one we would measure to. Now in this particular diagram we can see we've used 40 degrees because the angle of flooding and the parallel line that we've drawn, both of those values are more than 40 degrees. They occur at more than 40 degrees. So we use the least value, the 40 degree value. And we'll have a look at in another video on how we get these values. But they're the basic requirements for grain rules.